Hey, welcome to another adventure in old code. Today we're going to continue looking at Battle. And we will look at the player versus computer today. All right, let's just have a recap of the game. So we're given this grid system. And we have ground troops, and the computer has battleships, and one-hit kills. And so I select a row and a column. Oh, we missed. Submarine hit, infantry dead. So at some point there are submarines, cruisers, destroyers, battleships in the water. I'm not sure all what's on the ground. Obviously infantry. Destroyer hit. Oh, missed. So the other thing that I don't get to do is to place my troops. The battleship is hit and the foot soldier is dead. You know what? I'm sure the colors coordinate themselves. So the infantry is the same color as the destroyer and the foot soldier is the same color as the submarine. Yeah, these are not actual real ranks or positions or whatever you army folk call them. Curiously enough, the only ones who watch my video are part of the Canadian military. I think that must be a prerequisite to watching my videos. Hey, and if you're watching and you're not actually part of the military, let me know. Anyhow, okay, so let's have a look. I'm sure this will be a lot of similar mechanics as the player alone, but it'll be a bit different. We have a smaller grid, 10 by 10, and the computer's actually choosing to shoot me and everything. Okay, so let's have a look at this. We'll clear the screen. Remember, this was our outer program loop, and this is where we select player versus computer or player alone. And then the rest of the program really is in one of these two cases. So we looked at case A last time. Case B, we go to intro 2. What is that sound? Sorry, something really weird is going on in this room. Okay, well, whatever. I'll try and edit that part out. Okay, intro 2. This is the welcome screen where I tell you to pay me $5,000. Launch 2. Everything with player versus computers, obviously. Number 2. Whoops. Okay, so we're only 10 by 10 this time. But what's interesting is we're using the same C variable, C array. You remember C was an array, a 20 by 20 array to represent the grid for the player alone option. Now we're doing player versus computer and we only need 10 by 10, but I still use the same array for your, I don't know if it's for you or the computer's grid, but you can see that I've also got C2 and show 2, which are 10 by 10s, which are specifically going to be player versus computer. And it looks like I just hijacked the original arrays and use them for the player versus computer as well. So there's a bit of wasted space going on in computer memory at this point. Actually, there's not, because I declared them regardless of which option I chose. So yeah, that's actually okay. They're going to be there in memory regardless of what game I choose to play. So might as well use them. In reality, no, I shouldn't. Memory is cheap. Even way back then, that amount of memory was cheap, and it would have been much better if I would have used its own dedicated array, but that's all right. Okay, so we're going to, for each cell, for all 100 cells, the C variable, C array will get set to 0, C2 will get set to 0. Remember, this is points. This is the points that each cell gives you when you hit it. And the show arrays will be CHR string of 254. And that is going to be that funky block. So for player alone, we used 177. Now we're using this small square block thing. Okay. So show is what we're showing on the screen. C is the points that we get for hitting that square. Okay, for submarine equals 1 to 20. Okay, they're going to be 20 submarines randomly positioned in the sea. Okay, we're setting both your the ships or the troops that are worth 1 point. We're setting them for each grid system. We're calling it for submarine equals 1 to 20, but I can't remember what the ground troop equivalent of a submarine is, and we don't actually see it here. So yeah, just 1 second. So anyway, so we choose a random spot for all 20 submarines, and we set the C array to be 1, and we do the same thing for the ground troops, and we set the C2 array to be 1. Okay, and then the destroyers similarly. So each ship will have its analogous ground troop, and there will be 10 cruisers worth 3 points. There will be 5 battleships worth 4 points, and that's it. Okay, so we're setting all those troops, and then we do shoot 2. Ugh. Okay, this is how we're printing the screen. For each row, we're going to print first some spaces. My. Okay, there's a variable called my that's set to 0. Got it. For each column, we're going to look at what we're showing for the computer's grid, and we're going to do something analogous we did to the player alone. So if it's a block that hasn't been shot yet, X will be 9. This will be the color. So we're going to choose blue. If you've missed, it's white. If it's a submarine, it's orange. A destroyer is cyan. Cruiser is red. Battleship is purple. We change to that color. We That is a new command. Wonderful. Okay, so locate row and then pause my +1. I can't remember what the pause command is. A device IO function that returns the current horizontal position of the cursor. That's not quite right because we're actually passing it a value. Oh, no, okay. No, that's right. So we pass it a value, and it returns the... What? Okay, I'm really confused. What does that do? So the first time through the loop, my is 0, and then we're locating row of the pause. Okay, you know what? We are going to do some debugging. So we're going to put a breakpoint here. Actually, we're not going to put a breakpoint here. We are going to introduce a new variable called temp. And that is going to equal this value. Okay. And here we're going to actually just use it. Okay, so now we can actually put a breakpoint here. And we're going to set some watches. We're going to set a watch on my. And we're going to set a watch on temp. Okay, and then we're going to restart the program. And we'll choose player versus computer. And here we go. So we're drawing. Okay, so my is 0. That's what this is the first time through the loop. Temp is 5. Now my... Interesting. So my was 0. My plus 1 is 1. So this will look at the current position of the horizontal position, which right now is at 4. You know what? Let's add another watch. No, I don't want that. Here, let's break out of here. Let's add another temporary variable. No, let's call it something better. Pause 0 equals pause of 0. Actually, let's take that and put it above here. Okay, now that we've figured that out, now let's run it again. No, let's not run it. I have to add a watch. Ah, shoot. Sorry, folks. I have to add a watch on pause 0. Okay, and let's begin. Okay, so right now pause 0 is what you get when you put in 0 to the pause function. And I guess the pause function returns the horizontal position of the cursor. This is at 5. This is at 5 because we've printed 4 spaces. 1, 2, 3, 4. So, and then we've stayed on the same line because we've put a semicolon. And so because of that, the current position of that horizontal current horizontal position is at character 5, apparently. Let's put a breakpoint here. So we continue. And now my is 0 again. Pause 0 is 8 because now we're the second time through the loop. And we've printed another 4 spaces. Temp is now the position of my, which is still 0 plus 1. Now temp is 8, and so now we're locating 8, 8, and we're printing what we're showing. Next column. We keep doing this. Now it's 11. We do the next column. So this is keeping track of the horizontal position. I'm just a little bit confused as to why we're doing it this way. Let me delete all watch. I don't quite think I'm using this pause function. Let's reopen this program, not save it. I made a lot of changes. So for each column, we're actually printing 4 spaces, but I don't see the 4 spaces that we're printing. Where's the 4 spaces we're printing? I see 4 spaces between the... Oh man, this is frustrating. For every row, we're... Okay, you know what? We'll just make them ampersands. Where do the ampersands show up? Okay. So it's the beginning of the line. Well, that I should have probably realized that. And so for each column, we're going to... Okay. I just don't understand this pause my plus 1. Because I'm locating... You know what? We're going to go to a new program here. Print hello world. Then I'm going to print pause of 0. Then I'm going to print pause of 5. Hello world 1 1. Now it's 1 because the cursor went to the new line. What if I did that? Okay, I'll just put them here on the same line with semicolons, 12 and then 16. Okay. All right. It actually doesn't matter what is inside here. It was 12 because we were at position 12, but then we've added a space, a 12, and another space, which is 4 characters. And so the next time we call the pause function, it's at 16. It does not matter at all what is inside the brackets, as long as you have something inside the brackets. That is really weird. What does that matter? Okay, thanks QBasic for being confusing. That was a whole lot of rigmarole. Yeesh. Okay, so that actually returns the current position of the horizontal position of the cursor, regardless of what is actually inside here. So yeah. I didn't have to do that. I don't know why I did. Oh, because we're locating that row, we have to use it in a locate statement. So maybe that's why I'm using it. Okay, regardless, let's continue. That's really weird. Okay, then we're printing what we're showing, followed by 2 spaces. So there's 2 spaces between each column. Next column, then we're printing 5 spaces. Remember, that's the string command. It prints this character this many times. 5 spaces. My becomes the position, the horizontal position of the cursor once again. And we go through each column. And this time we choose the same color scheme except for the ground troops. Foot soldier, infantry, tank. What's an S? No clue. I have no idea what an S is. Not a submarine. Then we locate row and the position. Yeah. See, I'll bet that I thought I had to throw in a +1 here. But if I think what I actually wanted was something like that, and in reality, oh no, that wouldn't have worked. I think that's maybe what I thought I wanted to do. Okay, then we go to the next row. This is a very complicated printing. Okay. Let's try one more thing. We'll put a sleep here. We'll put a sleep here. Let's see this being drawn. First we draw all those, and we draw all those, and we draw. That's how we draw it. That's it. It's nothing complicated. I just did it in a very confusing way. All right. Okay, next thing we're going to look at. I'll have to make this episode more exciting. Okay, and then we print 4 spaces. I really like the string command here. How many are dead out of 50? Another 29 spaces, and how many of the other grid are dead out of 50? Oh boy, this is all funky. So shot string is going to be what happened last time in the C. Shot 2 string is going to be what happened last time on the ground. And rather than clear the screen every time, in this particular game, I'm erasing words by putting the precise number of spaces over them. So I'm going to locate this very specific place and put this many, the length of the shot string, and CHR string 32 is a space. I could have just used a space, but no. So I'm overwriting spaces on all the words, even the row and the column prompts. Then I'm putting 720 spaces at 13.1. 720 spaces will be 9 complete lines of spaces. This kills 9 rows all at one shot because it wraps around. Okay. Then we locate the same place. Wow. Print row. Then we go back. What? What? My head hurts. Okay. We're erasing all of these words. What happened last time? The length and column. The +5 is because we're erasing also your input. I'm not sure why I chose 5 and 8. Whatever. Then I'm printing 720 spaces, which will erase the next 9 lines. Then I'm inputting row. Then I'm printing those 720 spaces, printing row, and asking for column. Why did I do that? I could have just inputted row and then inputted column. But I inputted row, erased everything, printed what you just chose, and then input column. Okay, whatever. And then loop until your row and your column are valid. And then we look at what you did. So if you missed, show becomes X, submarine hit, destroyer hit. This is all from before. Cruiser hit, battleship hit. Every time we increase dead. Otherwise we missed. That's all shot string. And now we're going to let the computer choose a place. So we're going to choose a random row and column until we keep choosing that random coordinate until it's a place that the computer hasn't shot at before. So loop until it's a empty ground tile that's showing. And then we're going to look at the number of that tile, that cell. So same kind of thing here, just into the dead2 variable. Foot soldier, infantry, tank, SAM launcher. Okay. This is terrible. Then we're printing a whole printing a whole whack of spaces at 16:1, going back to 16:1 and then printing shot. It probably would have been easier just to clear the screen at this point. So we print what you shot at, we print what the computer shot at, and then we loop until one of you has killed everything. Ay, ay, ay. Okay. And then we go to ending 2. Hi, welcome to the end. You killed this many of his ships. He killed this many of your troops. If you won, then... Oh no, if you lost... You lost, you der. You won, you der. Give a percentage. All I can say is you suck. Well, that's not very nice. Okay. Loop until dead equals 1 or dead equals 2. Or dead 2 equals 1. Let's do this. So the first kill, destroyer hit. Ooh. Hi, welcome to the end. You killed one of his ships. He killed one of your troops. You killed 100% of what the computer killed. All I can say is you suck. Go again. All right. Well, that's battle. That was a lot of crazy ways of erasing text. Not the clearest, but oh well. All right, what can I say? That was Battle. Thanks for joining me in this adventure in old code. Have a nice day, and we will see you next time.